model so that we can learn the relationships between X and Y, right? And so therefore, only then we can make predictions for the new data set where we do not know Y. Same thing here as a human being, right? Okay, okay. We, the parent, will show the children the diagram of a duck, right? And will tell the child what is the relationship between what is the picture and what a duck, how to pronounce a duck, right? And so this picture will be used to make decisions about the duck, right? And so always remember we have a training data set, okay? If you are supposed to do that in your assignment, and then we have a new data set, right? Okay? So mostly we do is we use the node training data set where we know, right? And we try to predict what is the algorithm, right? So we have to, so in your experiment, in your lab task, no, I mean in your assignment, I think you do three algorithm, right? Okay, you do a minimum of three algorithms, right? And that's where you learn which algorithm is the best to come up with generate a model. And based on that, then you select the model, then you do then you submit in a test data. So I want to see that in the except in your lab task. I'm not lab task, in your assignment. Okay, you're gonna do well. So you have to spread out the training data as well as the test data, right? Okay, and then after that, you submit the training data in your three algorithms that you have selected based on your data sets, right? And then you come out with a model. Now with this model, then we put in our test data to make sure, right, that they are what we expected them to be. And this is what supervised learning is, right? So same thing as the kids are, okay? Okay, we train them to recognize all the pictures, aeroplane, duck, train, and so on. Right? Ultimately, when we show them the actual picture, right, they are able to tell us whether it's a train, whether it's a duck, whether it's an aeroplane. Right? And so therefore, we have what we call a training set. Right? And this is used to fix the model with the algorithm and try to get the features. Okay, and train to fix a model. Then we have a validation test, right? That means we have a sample of data used to provide an unbiased evaluation of a model that fits on the training data set while trying to tune the model hypoparameter, right? So what is this hypoparameter then? Right? We actually use that to choose what is the right parameter for your estimator, right? Okay, like for example, duck. So which features the duck has beak, the duck has web, the duck has feathers. Which do you think, right, will validate that this is confirmed to be a duck, right? Okay. So that means the what we call the training hyperparameter, the classifier, right? What we think we use to classify as a duck. So this will help us to get most of the optimized model. Then then you give them things to test it out. That's a testing data set, right? And that will give an unbiased sample. So let's say you want to train the machines is trained to learn the duck, right? The machine is trained to learn the duck, and you show the machine a chicken, right? That's a testing set, right? So is the machine able to tell them that this is a chicken or a duck? If the machine thinks it's a duck and that picture shows it's a chicken, the machine will say wrong, right? But if the machine says duck, then something is wrong, right? Okay, now if you actually show them a duck and the machine says it's not a duck, then the machine is wrong. But you show them a duck and the machine says it's a duck, and then it is correct. So test is the testing set. Understand? So I want to see a training set, a validation set, and a testing set. Right? I think we have shown that in the example that's been given to you in the video. When in the runtime video, you can see people doing that, right? Okay. So how to pick out your data set, right? Two aspects. One is how many samples are there in the data, and the actual models that you will be training, right? Whether it's a linear regression, random forest regression, or logistic regression. So therefore, sometimes a model needs quite a big amount of data to train upon. So in this case, you have to optimize, get a bigger training set. Models with very few hyperparameters, you can easily validate the tune. And so you can probably reduce the size of the validation set, but your model has many hyperparameters, then you must have a large parameter set. Right? What actually is mean is that, okay, let's say the features of the duck. I always like to use the duck, sorry. The duck has a beak, the duck has a feather, the duck has web, the duck has two legs, right? Okay? And so there are so many different things you want to talk about the duck, right? So therefore, you have, let's say there's so many things, but in order to point that to be a duck, then you must have big hyperparameter. Okay, you have a, okay, you must have big validation set. I'm sorry, you must have big validation set. Okay, so if there are, okay, okay, then you have to have a large data. But if you just want to identify a few things, right, no need to fine tune, just a few, like for example, the two legs means duck, right? Then you just put in a small validation set. Okay, but besides bird have two legs, what else have two legs? I'm sure some animals have two legs, right? Besides bird have two legs, what else? Human being has two legs. What else has two legs? So that is not a correct hyperparameter, right? Too few already, right? So you have to choose more so that the machine can accurately identify that is a duck, right? Okay. So therefore, okay, if you have a model with low hyperparameters or cannot easily be tuned, then you don't need to validate at all, right? So certain things you do not have anything that you can validate, so then don't need to validate at all. So this is an example then, given the training set, the validation set, and the test data. Right? So when you talk about test data, be careful. So you must insert the data that, for example, duck, you put a data called not, it's like maybe an elephant. So the machine should be able to tell you that this is not a duck, right? Okay. Now, and if you were to put a duck there, and the machine is able to tell you that this is a duck, so that is what we call test data. Okay, I want to see test data in your assignments, right? So validation set is a set of sample data we help back in training the model and use that to give an estimate of model skill while tune your model hyperparameter, right? So different from the test data, which is also held back on the training set, but is instead used to give an unbiased estimate of the skill of the final tune model when comparing or selecting between the final model. So usually you have a big training data set. You use one set of data for training purposes. Then you help back, okay, certain hyperparameter features, and then use that as a validation test. And then you help back some more, and you use that as the test data, test set, right? So a validation set is also play a role in the other form of model preparation such as the feature selection. So usually finally the final model will fix on the additions of all the training and validation data set. So validation data set is not enough, right? There are other ways to tell whether it is biased or not biased, right? Okay, okay, and so sometimes you can use what we call unseen data, data you have not seen before, so we just extract them out, okay, and then use the K4 cross validation to fine tune model hyperparameter instead of distinct validation set to avoid overfitting. So this is some of the methodologies, right? So you can see here that the height and the weight and the back toenails, right? These are independent variables of the features. Okay, variables that related to produce the outcome, the species. So the species is actually the outcome, that will depend on the height, the weight, and the back toenail. So that's where we use to predict. So if we think that the weight is the height is 4 meter, and the weight is 7,200 kilogram, and the back toenail is 4, then the machine will say that this is a African elephant. Okay, so the species will be the outcome based on the independent variable, where is the height, the weight, or the back toenail. Okay, so there are two types of regression. Today we will learn linear regression. Okay, other days we will learn logistic regression. I think Nick, you have learned Power BI, right?
Yeah.
Power BI also have done this already. Okay, you have done linear and logistic regression, right?
Yeah.
So for you, I think this should be chicken feed for you to discuss that, right? Okay, okay, and what is the difference then? Okay, why do we use linear regression and why do we use logistic regression? Right? We use linear regression if we predict a continuous variable. Why? Right? Okay, continuous variable means you came out with a value. You do a prediction. Okay, like example, we predict the price, okay, of the tariff in your country, of the goods in the country imposed by Donald Trump. So, right? Okay. But logistic regression will predict a discrete Y value, right? Okay. Example, whether it is smoking, whether there's an effect, is smoking related to cancer? Either yes or no, right? So that is discrete variable. Yes or no, right? Or for example, does heavy drinking links to drunk driving, right? So if you drink a lot and you are drunk and you drive, right? So most other people who drive and they drink definitely got accident. So either yes or no. So this is a discrete variable, one or zero, either way. Okay, one or zero. So logistic regression, we do it in the next lesson. Today we'll talk about linear regression. So if we have, I think this is done in statistics, again, things at the advantage. Okay, if you want to fine tune variance, how spread out the data is, right? So usually we look at the mean. The mean is the average value, right? And we want to see how accurate our data is, right? Okay, how accurate our data is. So that means, is there a relationship between variance of dependent variable and independent variable? Okay, you look at the diagram, right, for low variances. Okay, so you can see that all the red dots are in the red circle. So we can say that in this case here, the mean is a red circle, and those data set is not far away from the red circle, and so therefore we can say that the variability is low or the variance is low. Now, if the data, if the red circle has and if all the black color dot data are so far away from the red circle, then we can say that it has a high variance. Okay, we can say that it is a high variance. So, so therefore, in order to measure them, we use what we call a normal distribution graph. Normal distribution is a bell-shaped curve. Okay, you can see here, right? It's a bell-shaped curve, right? That means in the center is the mean. Okay, the center is the mean. Now, if this is a very symmetric on the left and right, usually the mean equals to the mode equals to the median. Okay, and so therefore it has to be symmetric around the mean. Okay, so if it is symmetric, if there is no bias between the left and the right. If it's skewed, then there is biases. Okay, so that's the difference, skewed and non-skewed. So normal distribution means on the left 50%, on the right 50%, and so therefore there's no bias left or right. Okay, so So that's why we have the standard deviation. How far did it differ from the mean? So the variance is actually the average of the square difference of measured data to the mean. So that is the average difference of measured data from the mean. That means the square root of the variance, right? Okay, so that is, you can see here, right? Okay, can you tell me the green color, the blue color, and the red color? Which one has low variance? Me, you learned before, statistics. So can you should really tell me which one has low variance? The green color, the blue color, or the red color?
The blue color.
Very good, thank you. It's the blue color. Right? Why? Because you can see that it's a very tall,
Yeah,
right? And most
narrow.
of the things are centered around the mean. Okay, so the blue color has a low variance.
Variance.
And you can see that the red color is so spread apart, right?
High variance.
So far spread apart from the mean, right? And
Yeah.
so therefore, and that is the high variance. Right? Now, data set are actually historical, training data sets are actually mostly is historical data. But usually some students predict, I think a very favorite project that most students do is predict the share price, right, of a company. And so based on the share price of the company, usually based on historical data. That's some example, right? Okay. So so what you want to ask is, let's say the original phrase is she is the president, and the Google is going to translate from English to Turkish and to English, right? And it becomes he is president. She is cooking and he is cooking, she's cooking. He's a nurse, she's a nurse, right? And she is driving a truck and he is driving a truck and so on, right? So there could be some inherent bias here, right? Why? Well, it's supposed to be a she is the president, right? But then the Google, when it translates it down, it becomes a he, right? Okay. I'm sure there is sometimes when we write an essay or in English, we always refer it to him, right? Instead of her. Okay. So non-random sampling, that means it's not representative of the population that it is trying to model, right? Meaning to say that you don't just pick up, let's say we have a bag of ball, a bag full of ball, right? Random sampling means we just put our hand in and just pick it up. Right? Non-random sampling means to say that you put maybe all red balls, right, into the bag, and then after that we pick it up, we understood that we will get a red ball because you put all red ball inside there. So that is a theory on machine learning, right? And now we go in depth into variables in linear regression. As we said just now, linear regressions, right, involve one dependent variable and one independent variable. Independent variable is the x, and the dependent variable will be the y, right? And so therefore, we will try to predict what is the y based on the changes in x. Like for example, we want to predict what is the share price of the company for tomorrow based on the past historical data, the price in the past. So therefore, we would have many x variables, and then we call them the multiple linear regression. Okay, meaning what do you mean by that? Multiple x variable. Okay, maybe multiple features we're talking about. Okay, besides the share price, besides the price of historical data of the stock, what else do we look for? If there are a lot of things that we look for, then we call multiple x variable. Example, right? If it just depends on one features of a duck, like the beak or the two leg, right? That means there is only one variable. But you're going to put multiple variables inside there, right? Like the beat, the feathers, and so on. And so you have what they call multiple linear regression. Right? So other forms of regression, you will have the logistic regression. in this course, we'll focus on linear regression and logistic regression. So we are not going to focus more on others. So remember, we talked about just now, linear regressions are continuous, the value variable is continuous, and the line is linear. The line is linear. So this type of prediction will predict continuous y value. If I'm going to give you a vectors of x values and a vectors of corresponding y value, right? Okay, and you get a corresponding y value. Then ask you to estimate y value for new x, not in the original vectors. What are the options? In this case, yeah, right? So therefore, you will able to plot something like this, plot the data and decide whether the linear relationship between x and y looks like this, right? Okay, so this is a what you call a scatter plot. A scatter plot means I give you all the points x and y, right? So then you try to draw a line that best fits, okay, y based on x. So another way to pose the same question is to ask for a line of best fit to be drawn through the cloud of x and y point. So we need two things: slope, that's the gradient m, okay, or the gradient m, and y, the intercept. Okay, slope, the gradient y, and it doesn't give you get how it looks like. So this is what we have. Okay, so this is the gradient m, and this is the intercept. Okay, this is the intercept. Okay, this is the intercept, and that is the gradient. Right? There you are. So this x is actually your, okay, y equals mx plus c, and c is actually where the line crosses the x-axis. So you can see here there's the c, and there's the m, right? Okay, the gradient, and so on. Okay, so this beta 1 and beta 0 is actually, we can, another name we can give it is called the predicted coefficient for the variable. And the beta 0, we can call it the intercept coefficient per variable, right? Okay, so you can see that this data is scattered, and you can draw two straight lines here, right? You can fill it with the blue line, or you can fill it with the orange line. Now, which line do you think best represent, best fit the data, right? The orange line or the blue line, right? Okay, so how are we going to get the best fit machine learning, right? So we make use of what we call a method of least square. Okay, method of least square means to find, then we took, so what we do is we draw a regression line, and then the dot, and how far is the distance between the dot and the straight line? How far is the distance between the dot and the straight line? And that is the least square method, right? Okay, and we call that the vertical difference, we call it error, and also called the residual of the regression line. Okay, we call it error terms, or we also call it the residual of the regression line, right? And so adding up of all these errors is going to be large for this line here. You can see that all the dots are here, but the line is far away from the dot, and therefore you add it up, and you can see that the error will be very big, and so we can say that it is not a good fit. Okay, it is not a good line. Now, if we're going to draw the line here, okay, and you add up all the error and give you little smallest error, and that is called the line of best fit. Okay, E is called, okay, the term E is error, and how good a fit is the regression. Okay, so some of the error or residual will be positive, and some will be negative. Right? So we will add up all the t terms from the point of positive. You will cancel out all the negative and give us a false measure of error. Okay, it all depends. Sometimes you got a big one on top, then big one. Okay, so here you see this quite big. This error is quite big on top, quite different, right? Or sometimes we add them together. Sometimes we can get error minus f e, or we can get a positive e, right? So how to remove this sign of positive e on the positive e? So we square them. So what we do, we take y1, the actual value, minus the predicted value, and square them. So if you got minus, we square them, become positive, no problem, right? Okay, and that's why we call squaring the differences and then add them up. Okay, squaring the differences and then add them up, and then the regression line with the lowest sum of the error or residue is the optimum, or what we call the best fit. Closer to zero, the better. Okay, closer to zero, the better, right? So assumptions of a simple linear regression, right? So we say, well, the linear regression relationship here, right, is between independent variables and dependent variables. The x is the x-axis here is the independent variable, and y-axis is the dependent variable. And you always assume that the error and the residue have a normal distribution, right? Means to say that any differences between the dot and the line, right, is normally distributed. That means to say that, right, the variances, right, should be small. There is a constant variance of standard error against the predicted independent variable for the best decision. If these assumptions are not met, the model may not be very accurate, or worse, it could be seriously wrong. So all these three assumptions must be there. Okay? Now, what happens if you have different factors? That's like the economy of a country. Right? Economy of a country does not only depend on one factor. Right? It can depend on different factors. Right? That's why you want to predict a duck. Right? Okay, there are so many features in the duck to accurately pinpoint that this is a duck. Right? So there's many variables there, right? And so in order to describe them, the line of best fit, right? We can use y to the beta 0 plus beta 2 minus beta and so on and so on, right? So this beta is called the age, the weight, and sometimes it will be set to 0, right? So that we and so we use this equation to try to do our prediction, the values of y on a new data set where we do not know. Okay, for example, y is sales is based on the marketing strategy, right? So the different marketing strategy we use. We can give promotion, we can give a discount, we can give and so many things. One for one free, right? Okay, and so we see that which will sell more, which strategy, marketing strategy will sell more, right? Okay, so if you use R, right, in R Studio to conduct linear and so on, right? So and scientific kits is used scientific-learn.org. You will use regression in Python. Okay, so that is what linear regression is. Any questions? No one. Okay, to get you please. Okay, I hope that by now you should have selected the data, the environment, CAP, that's what you've done in the last few lectures. And now, after selecting your data, you are supposed to do data cleaning, right? Okay, data cleaning. And then after that, you do your lab on linear regression. And next week, I will recap on linear regression. And then you are actually on the way to do your assignment, right? So I have sent this file to you. I have also sent the data file to you. Okay, I sent this file to you, data.csv. Okay, I've sent this data.csv file to you. You can see that there's a name, surname, year of birth, and locality. Right? There's name, surname, and that is the data file. Okay, and to run this data file, okay, and I also send the Python programming to you. Okay, I also send the Python to you, and so this also has been sent to you, right? And import. So first thing you do is to import Panda as PD, and okay, from non-Python import NAN, right? So data will be equal to p dot read CSV, okay, data.csv file. So my file is Microsoft Excel. I have converted it into data.csv. So you are supposed to select a Microsoft Excel dataset file, and the condition has been given, how many rows, how many columns you have to do. Please, I can't remember, please read the assignment, right? And then how to open the file. Okay, so I'm teaching you now how to open the file, which actually, if you've done your lab, you should know what to do. Okay, for the last few sessions, you'll be doing that, working with data. So data equals to pd.read CSV and bracket the data CSV file. Then after that, you, okay, create a data frame, okay, into PDF. And then you print your data frame. PF stands for data frame. So when you print your data frame, this is what you have. Okay, you see the output here? Okay, you see the output here, you have print the data frame, you have name, surname, year of birth, and locality. Right? Now after finishing this, last week I teach you how to do the statistics one by one, so troublesome. Right? In Python, right, you can use the word print describe dot data frame describe. When you print data frame dot describe, it will describe here, okay, for you. Like for example, the count, the mean, the standard deviation, the minimum, 25 percentile, 50 percentile, 35 percentile, and maximum. Right? Okay. So you can see that in the previous last lesson, I do it one by one, right? But now I give you a function that you just put data frame, print data frame dot describe, and it will describe to you the count, the mean, the standard deviation, the minimum, and the maximum, and so on. Okay, so all this you must do. First you get your data set, describe the data set. Okay, why you want to do this is because you want to know whether there's anything that you need to do. Right, then after that we rank the functions, right? How to rank them? We just put data frame dot rank, right? And then for we rank them, right, into 0, 1, 2, 3, 4, 5. First, okay, into okay, so you can see that they're all arranged in numbers. Okay, arranged in numbers, right? Okay, and then you can see that we have then we're going to find out missing value. Okay, missing value. Find out any value that is missing. So we print df.isnull now is now, right? See whether there is any zero value or not. Okay, if there is, then we have to print them out. And then after that, we have to remove. So you find there's a missing value, you're supposed to remove the value. And so to remove the value, we put drop number. Okay, let's say the no thing one, we just do drop the number. Right? Sometimes we want to replace those, okay, either we don't want the number, right? Or sometimes we just want to replace it with another number. So so we just put df dot replace. Okay, in this case here we have NaN, right? You can see that we have NaN, right? So we want to replace NaN with 0.00. So this is how we do the replacement. Okay, so you can see that you want to replace NaN with 0.00. So that is how the command we use to replace. And finally, you want to remove any repeated value. you just put df dot drop duplicate. So any value that is duplicate, they will drop it. Okay, they will drop it. Okay. Now sometimes you want to rename the column, right? You want to rename the column, so you just put rename column name, first name, surname will become the last name, right? Surname will become the last name, right? So you can see here, right? This one I give it to you already. Yeah? So you can see here. So sometimes I want to rename the column, right? Surname becomes first name, and okay, name becomes first name, and surname becomes the last name. Okay, become the last. So I rename the column. So all these are important features where you can use for your assignments. Okay, I'm giving you all the steps already. Oh, okay, make it life very easy for you. You all the steps. Those steps you don't know how to do. Okay, by right, you're supposed to experiment the step yourself because the notes are all over the place, right? So I just give you the different steps you need to do, what you need to check to clean your data. This is what we call data cleaning. Okay, Ken, you need to clean all this data, right? And then let's say that I don't want the column here above. So I just start delete data frame, okay, and then here YOV, and then print DF, right? And so you can see here, right, that, okay, you can see here that the year of birth has been deleted. Okay, the year of birth has been deleted. So all this command, I give it to you. I send it to you already. Even the data set I also send to you. And look at it, how you play, how you run, and use this for your assignment to do cleaning. Okay, so now today, after today's lesson, right, you should be able to come out with something, a data set. You should be able to do cleaning. Okay, then the next lesson, you only learn one linear regression, right? I will teach you how to fit in the model and train the model, right? And then I think you, then after that you experiment with more models, and then you should be able to finish your assignment. Okay, not that difficult? Difficult? No, So you are already 50% there. Okay, after I give you the how to fit the model in, right? Then after that, how to train the data. That's it. Okay. Then after that, you get a predictor. Oh yeah, one more. How to measure them? Okay, KPI, key performance indicator. Yeah, forgot about that one. Okay, how to measure them? Make sure it's the correct measurement. That one will be the last part, lah. Oh, then after that, the models are the same. I mean, not say the same. The steps are the same. Okay, the steps are the same. It's just that you just put in different libraries as well. Okay, the steps are the same. You just put in different libraries. Now, if you look ahead and do the lab task, right? If you do ahead, look at the lab task actually will tell you what to do. Okay, the lab task actually will tell you what to do. But for me, I put them together so that it's more structured for you. Okay, so the more structured for you, then you know what to do, lah. Or else, all over the place, you don't know which one to fit in. Oh. Okay, any questions so far? Everything okay? Huh? Okay.
So for Visual Studio, do I have to install some compiler?
Visual Studio, yeah, they will come out. The Visual Studio, they will come out with the Python debugger. Usually, you use a Python debugger.
It usually goes through the terminal actually for me.
They will ask you for the debugger. What you want, you just Python debugger.
Okay.
That's all.
Okay.
Okay. Unless unless you do your project, you want more like more things. But you're not
Okay.
doing project.
Okay.
Okay. I think those are doing project under me now. They are doing more things. All want to do machine learning because it looks easy.
Yeah.
Okay. Okay. All these files are data files are given to you. Okay, and Python files are given to you. Okay, so you can go and play with it. And these are the steps usually we do. What we do, what we check. Okay, first we read the statistics, describe the statistics. Why we want to do that? Later on, by right, you're supposed to give you the box plot as well. Oh, but I give you the basic first. Okay. So, okay. Any questions so far? Okay. If no question, then you can start on your lab, right? Task. I think by next week you should be able to fit in a model. Okay. I'll just teach you 2 or 3 models. The rest of the model you have to, but I'll tell you the theory, but the top software aspect, you have to do it yourself. Do the tutorial and do it yourself. Okay? And then after that, I'll teach you to do the training, data set, how to do it, and that's it. Okay? So now is the pre-cleaning. Okay? Okay? So this is what we call cleaning the data. Okay? Cleaning data. So what you need to clean now. And sometimes when you clean the data, right? You want to rename the column, what you do. You want to delete the column, what you need to do. Okay, sometimes you find the column you don't need, right? So you need to delete it off. So all this, you show it in your, what you call it? Show it in your exercises, Okay, don't just put, oh, this is the data, raw data, and this is the clean data. You show me how you do the cleaning. Okay, you just put the comment there, data cleaning. That's what I show you in the, in the previous students' assignment, right? And when they do the presentation, oh, and with the comment that this is data cleaning, what do you click? Okay, okay, and so on. Okay, okay, any questions? So you can keep this, this file is very important, it can help you with your assignment. Okay, this file is very important. You can use this file to help you. But of course, there are other things that you want to do, you can always do them. Okay, so if you don't want to delete a column, so you can take out the delete column. Okay, can the delete command. If you don't want to rename the column, just take away the rename command. Simple as that. Okay, so this is just to give you, just in case students sometimes want to rename the column, and sometimes students want to delete a column which they think is irrelevant, and so on. Right? So these are some of the possibilities that you want to do, so that's been given to you. Also, this is what you learned today, huh? So can you go through this? There you are. So by right, you're supposed to draw a box plot as well. The box plot will tell you what is the out here. The purpose of drawing the box plot is actually what is the out here. Okay, next week you'll go through more. Yeah, you see? That's why you need to know the mean, the medium, and the mode, right? Okay. So please go through this task. Some of these you don't need.